Hmm. Let me just restart my browser. Oh God. This one. Yeah. Hmm. Hmm. In place. Ah, I see. Hmm. Try this again. In place or no? Doesn't work. Mm-hmm. Own now? What? Hmm. doesn't work. Huh. Thought deep copying would work. Guess no. Hmm. Really? Hmm? Oh, that doesn't make sense. I can't clone it. One of the variables needed for gradient computation is modified in place. Another solution is to use clone, but I can't clone the scheduler, I guess? Or do I need to copy the... Maybe clone this on the tensor itself, maybe? Grad tensor. Could be. Could be. No idea though. Oh, oops, not that. And yeah, DeepSeek.
Yesterday, China released a state-of-the-art free and open-source chain-of-thought reasoning model with performance that rivals OpenAI's O1, which I'm stupidly paying $200 a month for right now. You see, there's two types of people in the tech world right now. In one camp, we have the pessimists, who think that AI is overhyped and plateaued with GPT 3.5. In the other camp, we have the optimists, who think we're about to see the emergence of an artificial superintelligence that will propel humanity into Ray Kurzweil's technological singularity. Nobody truly knows where things are going, but one thing to remember is that pessimists sound smart while optimists make money. But sometimes it's hard to be an AI optimist because you need to trust hype Jedis like Sam Altman and closed AI companies like OpenAI. Well, luckily, on the same day that TikTok's ban was removed, China gave the world a gift in return in the form of DeepSeek R1. And in today's video, you'll learn exactly how to use it like a senior prompt engineer. It is January 21st, 2025, and you're watching the Code Report. Yesterday, the course of history changed forever. And no, I'm not talking about the return of the king, but rather the release of DeepSeek, which is an MIT licensed chain of thought model that you can use freely and commercially to make money in your own applications. This model came out while Sam Altman was busy at Trump's inauguration, which is a perfect time to use this new meme template where Zuckerberg appears to detect a rack overflow in this artificial binary code owned by Jeff Bezos. He's going to have some explaining to do with his wife, but Sam Altman also rained on the AI optimist parade recently when he said that the AI hype was out of control, and no, they have not achieved AGI internally. And that's pretty obvious with how buggy ChatGPT is. Like recently, a security researcher figured out how to get ChatGPT to DDoS websites for you. All you have to do is provide it with a list of similar URLs that point to the same website, and it will crawl them all in parallel, which is something that no truly intelligent being would do. That being said, the release of O1 a few months ago was another step forward in the AI race, but it didn't take long for open source to catch up, and that's what we have with DeepSeek R1. As you can see from its benchmarks, DeepSeek R1 is on par with OpenAI O1, and even exceeds it in some benchmarks like math and software engineering. But let me remind you once again that you should never trust benchmarks. Just recently, this company Epic AI, which provides a popular math benchmark, only recently disclosed that they've been funded by OpenAI, which feels a bit like a conflict of interest. I don't care about benchmarks anyway and just go off of vibes, so let's go ahead and try out DeepSeek R1 right now. And they have a web-based UI, but you can also use it in places like Hugging Face or download it locally with tools like Ollama. And that's what I did for its 7 billion parameter model, which weighs about 4.7 gigabytes. However, if you want to use it in its full glory, it'll take over 400 gigabytes and some pretty heavy-duty hardware, multiplier to run it with 671 billion parameters. But if you want something that's on par with O1 Mini, you want to go with 32 billion parameters. Now, one thing that makes DeepSeek different is that it doesn't use any supervised fine-tuning. Instead, it uses direct reinforcement learning. But what does that even mean? Well, normally, with supervised fine-tuning, you show the model a bunch of examples and explain how to solve them step by step, then evaluate the answers with another model or a human. But R1 doesn't do that and pulls itself up by its own bootstraps, using direct or pure reinforcement learning, where you give the model a bunch of examples without showing it the solution first, then it tries a bunch of things on its own and learns or reinforces itself by eventually finding the right solution, just like a real human with reasoning capabilities. DeepSeek also released a brief paper that describes the reinforcement learning algorithm. It looks complicated, but basically for each problem, the AI tries multiple times to generate answers, which are called outputs. The answers are then grouped together and given a reward score, so the AI learns to adjust its approach for answers with a higher score. That's pretty cool, and we can see the model's actual chain of thought if we go ahead and prompt it here with OLLAMA. When prompting a chain of thought model like R1 or O1, you want to keep the prompt as concise and direct as possible, because unlike other models like GPT-4, the idea is that it does the thinking on its own. Like if I ask it to solve a math problem, you'll notice that it first shows me all the thinking steps, and then after that thinking process is done, it'll show the actual solution. That's pretty cool, but you might be wondering when to use a chain of thought model instead of a regular large language model. Well, basically, the chain of thought models are much better when it comes to complex problem solving, things like advanced math problems, puzzles, or coding problems that require detailed planning. But if you want to build the future with AI, you need to learn it from the ground up, and you can do that today for free.
Brilliant. Brilliant, yeah, for sure. Close eye AI
and closed AI companies like OpenAI. Well,
yeah. DeepSeek the goat. God damn it. Well, yeah, I can do it. I mean, I guess that's gonna happen. Guess we're all going through some stuff. Yeah. I mean, life. Life happens. Yeah. Yeah.
Well, luckily, on the same day that TikTok's ban was removed, China gave all the thinking steps. And then after that thinking reinforcement learning algorithm, it
Let me look
capabilities.
at this.
DeepSeek also
Group relative policy optimization. In order to save the training costs of reinforcement learning, we adopt group relative policy optimization, GRPO, which foregoes the critic model that is typically the same size as the policy model and estimates the baseline from the group scores instead. Specifically for each question Q, GRPO samples a group of outputs O1, O2, OG from the old policy and then optimize the policy or by maximizing the following objective: theta and beta or hyperparameters. And AI is the advantage computed using a group of rewards. I'm assuming they're just computing a lot of outputs, using it to, I don't know, depending on the output, then it rewards the model itself, I guess, making the model having to think about it again.
released a brief paper that describes the reinforcement learning algorithm. It looks complicated, but basically for each problem, the AI tries multiple times to generate answers.
Yeah.
Which are called outputs. The answers are then grouped together and given a reward.
Amy, OpenAI, O1 Mini, O1. Okay. R10, Code Forces, Live Code, GPQA, Math, and AME. IME? IME? DeepSeek.
Score. So the AI learns to adjust its
And given a reward score, so the AI learns to adjust its output. Marsh. Yeah. Uh, what should we do? What should we do? What can I do? I need to think. I mean, some of that could work. Not sure. That's hard.
Approach for answers with a higher score. That's pretty cool, and we can see the model's actual chain of thought if we go ahead and prompt it here with OLLAMA. When prompting a chain of thought model like R1 or O1, you want to keep the prompt as concise and direct as possible, because unlike other models like GPT-4, the idea is that it does the thinking on its own. Like if I ask it to solve a math problem, you'll notice that it first shows me all the thinking steps, and then after that thinking process is done, it'll show the actual solution. That's pretty cool, but you might be wondering when to use a chain of thought model instead of a regular large language model. Well, basically, the chain of thought models are much better when it comes to complex problem solving, things like advanced math problems, puzzles, or coding problems that require detailed planning. But if you want to build the future with AI, you need to learn it from the ground up. And you can do that today for free thanks to this video sponsor with AI.
Problem,
you need puzzle,
complex code, math puzzle, like general question is not really good. I mean, no, right? Not really. Maybe.
Or coding provides minutes of technology. You really is by Code Report. Thanks for watching, and I will see you in the next.
God. Things are not going well for me, I guess. Yeah. What is this?
This episode is brought to you by Ground News. Hi, welcome to another episode of Cold Fusion. As reported, struggles, and it was led by Ho Chi Minh.
You might have noticed I've been wearing this amulet, and I've got to say, I've never felt more at peace. This is the Aries Tech Life Tune, a device trusted by legions of celebrities and athletes to protect them from the dangers of 5G devices and radiation. Backed by peer-reviewed research, oh God, not that one! There we go. Backed by 22 peer-reviewed articles, there's apparently some serious science behind these things, and okay, no, I can't do this anymore. But it is true. We're constantly surrounded by more and more technology that is emitting electromagnetic radiation, and there are some credible sources that suggest that it can be bad for you. So let's demystify the woo-woo the proper way, with science. We are going to fully investigate this thing with our EMF chamber, our CT scanner, and our RF meter. Some serious equipment that costs some serious money. Maybe more seriousness than this deserves. And we're going to do it with some help from our sponsor, Hetzner. Their object storage solution is S3 compatible and grows with your data requirements, all at a great price. Click our link and use code LTT25 to save $20 on your cloud servers today. The first thing I noticed about wearing the Aries Tech Life Tune is how much of a conversation starter this thing is. Dennis asked me about my necklace. I said it protects me from 5G.
So your phone will, you don't get 5G, will be 4G, 3G. I said 5G. This is a fake, Linus. You got scammed.
Yeah, that is a pretty good point, but we'll talk more about that later. First, let's narrow in on exactly what claims celebrities are making about the Aries Tech amulet.
And as you know,
Yeah. Harsh. How do we go about this? I don't know really. I don't know. We'll figure that out. Figure that out.
Airports are places full of Wi-Fi and all sorts of evil energies. Think of all the phone.
Is he taking the piss? I actually haven't seen any of the marketing for this thing.
I'm not entirely sure. He's definitely serious about a bit of it.
I didn't even bring any socks or toothbrush or dog meats or anything like that. Just complete.
What?
You should get one as well, particularly if you're planning to go to an airport anytime too soon, because the bloody things are full of lethal signals. Airs Tech, a glorious amulet to protect you from corrupting signals.
Yeah, I bet comments are disabled. But dog meat aside, what we can glean from their website and from their press materials is that Aerostech believes that electromagnetic radiation is bad for you, and with this $240 US, please tell me we didn't buy it.
Oh, we got 2 of them, and 2 small ones. It was over $800.
But with this $240 US amulet, you and your nearby loved ones will be protected. But let's back up for a second. What is electromagnetic radiation, and why might you want to block it? Well, in simple terms, electromagnetic radiation is a type of energy that's all around us and that takes many forms, including microwaves, X-rays, and gamma rays. It can also be used for communication, and in the past, we used very slow radio waves that operate at about 20,000 hertz to maybe approaching a gigahertz in some applications. But the thing is, with modern technological advances, you now have many devices in your house that operate well above the gigahertz range, with many others operating well into the hundreds of terahertz range and outputting several watts each, including this. That's right, my friends. Another word for electromagnetic radiation is light. And given that you're probably okay with having light bulbs in your home, you should probably be okay with having a Wi-Fi router that is actually outputting at a much lower power. But it's not quite that simple. We need to dig deeper. In 2011, the World Health Organization added radiofrequency electromagnetic fields to their list of things that could possibly be carcinogenic to humans with a 2B classification. Organizations like Aerostech will point out that that puts radio waves in the same category as things like lead, exhaust fumes, and weapons-grade tungsten. But what they fail to mention is that it also includes things like aloe vera, ferns, and pickled vegetables. Now, to be clear, investigating if radio waves are bad for you is good work, and it should happen. But a meta-analysis of 300 studies by the Swinburne University of Technology in Melbourne concludes that radio waves basically aren't harmful at lower intensities. But even if they're not, there's still a lot that we can investigate about the Aerostech Lifetune, like, is it able to block RF? Well, given that it casts a shadow, we can conclude, yes, it can! Okay, sorry. I'll take this seriously for a second. Here, Alex, you take the Lifetune, and I'm going to hold this. This is an RF meter, which tells us the intensity of radio frequency electromagnetic radiation around us. So our current readings are somewhere in the neighborhood of 1.3 to 1.7 volts per meter. Alex, come closer. Aerostech advertises that the Lifetune has an effective range of 32 feet. That's why I sent Alex over there. Now that he's closer, we should... Oh, it actually kind of spiked for a second, and then now it's the same. Obviously, the Aerostech didn't do anything.
Let's see. We have to plan this out. We have to plan this out. We have to.
For real EMF blocking, you need something more like this. Our EMF chamber with a 6-figure cost. As you can see, when we go in here and close the door, and
Yeah, that works. We're down to millivolts per meter now. But
Yeah, right. Let me think about this. Hmm. This is hard. It is hard, yeah. What can I do? I just need to verify. Okay. Yeah, I'll do that later. Oh, hello. Hey there. How are things? Uh, pretty bad. Pretty bad. Yeah. What's wrong? Uh, let's see. Having a bit of problem with deploying or just working with some of the hardware and compute that I have. Then there's the interview that I did a week ago, which I felt and I know, um, but that's also one thing. And then there's yeah, the partner that was working with me on my project and my company also lost, well, they lost their family, that's one, and then they also lost their compute. Um, so yeah, that's a lot of things that went wrong. Not going well. Yeah. Yeah. A lot of things are going wrong. Yeah. No problem. No problem. Just gotta figure out my next move. Mm, let's see here. Mm. Did the company interview at least get back to you with a rejection? Or did they blank you? Well, it's not really a company that I'm interviewing for. It's like a recruiting company. So they basically do like, um, and do you know what went wrong in the interview itself? Yeah, I do. I do. Yeah. It's basically a middleman for companies. They do like uh interview tests, and then if you do good, they do like they recommend you to those companies. I did. I honestly thought I did badly, but turns out I did uh borderlinely good. Not like a pass, but decent enough, but didn't get a recommendation. Yeah. Most of the stuff I, not because I don't know it, but because I'm trying to find any silver lining to say that this hasn't gone as badly as it could have. Sure, yeah, the interview itself, I mean, it's not that I can't land interviews, it's just that this particular opportunity is like much better than the other ones that I had. If you know what went wrong, then at least you know what to work on next time. Yeah, yeah. Not really sure if I would interview again, because interview sucks, to be honest. The reason why I wanted to interview for this position because it was again good, a lot better than the other positions that I already landed, all which I turned down. And then it's also because I know the founder of the company, and yeah, they just introduced me to this opportunity, and I just wanted to kind of do well on it. And then the other thing is, um, I kind of knew going into the interview, like if it doesn't work, then yeah, the founder of the recruiting company, yeah. Yeah, I reach out and yeah, we talk on the phone quite a while back, yeah. Yeah, so basically knew going into the interview or just preparing it. I kind of crammed the interview like within a week. Um, but at least I know like it would not be possible to ask for a second chance. I was gonna plan to talk to them in a few weeks, yeah. I mean, a second chance, you can, they said on their website, you can probably interview again within like 6 months. Not really sure if I want to, but that's an option. I guess the only disappointment I have is how would I say? I yeah, like I don't like interviewing for the sake of interviewing. And so it's a guess you call sooner and had to schedule a second interview if possible in 6 month time. Yeah, yeah. I was just gonna call them um instead of asking for a second 6 month time. Yeah. I was gonna speak to them a bit on that. Yeah. Interview sucks, yeah. I don't I don't know, like interview sucks because well, there's no CEO unfortunately. Yeah. Doesn't have to suck. I like I guess having the interviewer to have conversation with you to talk about things technically would be better than just asking lead code questions, asking conceptual questions. That's much better. And so they have a process for this where there's like the coding section, there's the conceptual question, there's like the system design, and like that in practice, in on paper, it looks good, much better. And they do say that whether or not you fail or you pass, then you would still receive feedback, which is a lot better than companies nowadays. Uh, Normally they would just ghost you, so that's much better. The other thing though, um, yeah, I just know that these are things that are out of my control. The things that I do have control is what I learn. And so in that 1 week, I kind of stated like whether I pass or not, at least coming out of the interview, I got something to work on. Um, and I got a lot of things out of it that are kind of related to what I want to work on. And of course, that's, my company and my project. And so it's really to the job or the interview is to prepare or supplement that work. And so yeah, I kind of expected that I would fail. Um, I didn't expect that I would be doing kind of decent on it, to be honest. I thought I would do very poorly and badly, but yeah, I guess I did a bit better than I thought I would be. Um, but still, still a no. So that's that. I'll see what I can do, but Yeah. It is what it is. Yeah, it is what it is. Shit happens. Yeah. Life happens. Life happens. Life sucks. But yeah. Yeah, definitely. Yeah. Minor outside. Yeah. I guess it was also something that I haven't touched on a lot. It was like a full stack interview, like front end, back end, stuff like that. I was more into research and machine learning stuff for the past 2 months. So yeah, I had to dedicate like a whole week to it, which I spent like 14 to 16 hours on average each day. Um, I wake up like, yeah, I have like 18 hours every day. I use like most of my time for like preparing for it, um, which which is not uncommon for me, but it was kind of different spending just a whole week for interviewing. Yeah, I usually just wake up, um, spend my whole day at the desk, respect the work. Yeah, yeah. I was kind of also worried about the interview, and so I kind of want to discipline myself more. So rather than spending just usually like 12 hours, maybe somewhat not learning or doing stuff. Yeah, but really going into it. Don't know if that was as effective as it could be. Props. Yeah, it was effective though. Definitely. Like there's constant pressure to perform. So it was something different from my usual day. Like there was like it felt like there was a proper deadline that I had to work on. Um yeah, which was intense, but I guess also good. Mm. Yeah, for sure, for sure. Yeah, definitely. Yeah, definitely. I don't hate learning, so when studying and taking a longer while. Yeah, yeah, totally. Yeah, when I feel tired, I just watch some YouTube or watch some animes. I could could stand. Yeah, yeah. I mean, I'm not really pressured. That's also because I love just like learning new things. Um, yeah, so it's not, yeah, it's not a lot of work for me. And when it does, yeah, usually just watching some shows, having a bit of rest. Yeah, learning is awesome. Yeah. hmm Mm. Learning front end sound like yeah, yeah. I mostly learn about what is it? Just yeah, the front end portion was mostly like the different frameworks and like how they work, things like that. But it's been a long time since I touched that. Um, been mostly working with yeah APIs and web scraping. Um, yeah, mostly related to data. so not a lot of front end. You only hate yourself so much. Front end is something. Let's see. I watch the what is it? I think the front end portion. I think the video by Rich Harris was great. Yeah, yeah. Rich Harris, rethinking reactivity. He's the founder of, or like the founder or creator of Svelte, the framework. Yeah. He's like a graphics editor, and he built like a compiler, um, which is crazy. Yeah, so absolutely great talk. Like to tell me about, would you like to tell me about your company, which you mentioned earlier? What do you do? What do you work on? Sure, sure. How do I explain this? How do I explain this? So basically, actually I can pull this up really. I have Obsidian here, which I just learned the other day, so it might actually be good. Let's see. Yeah. Ooh, that looks bad. Okay, that's much better. So I'm basically building my animation studio, and the first thing that I'm gonna work on is building a tool for animators to better colorize, to basically automate that away. And so would be basically this, I guess. Um, so given a so usually animators would need to have their line art or animation be in black and white, and they have to color that in like this using some kind of reference here. That does make sense. Should have guessed from your stream title. Yeah. And so the work of the colorist is to basically look at the design and to like paint bucket, like choose the color and then paint bucket every single frame of like the animation. And that's usually about 3,000, 4,000 frames for a single 20-minute episode. What I'm basically building is an AI, a machine learning model that can basically take in the animation, and given the reference character design, the AI can automatically insert the character color in for the character. Yeah. Potentially, you can also have manual human input. Like if things doesn't work out, you can input certain points or like fix stuff where the AI doesn't do well, and it would just do the job. So that's basically what I'm building. Yeah. Right now, yeah. Well, hopefully, yeah, hopefully I can build out this tool and also use it myself actually for, because not only am I building this tool for people, for animators, but also to build it for my own animation studio. And so hopefully we can utilize it. How are you training it? What features are you targeting? How are you getting the training data? How am I training it? I guess that relates to data. So feature would be these two of whatever character reference that you put in and your animation. So it could be a different character, and then the AI would infer the color and just insert that. That's the basics of it. Feature implementing that. Also manual input, that's an extra feature. I mean, what features in input are you trying to target? Yeah, these three. Features would be like animation sketches. That would be like black and white input of animation. Is it multipass or trying to do a single pass? I was thinking only of a single pass because most systems, most multi-model systems are single pass. Maybe multi-pass could be an option. I haven't explored that. Good idea though. Yeah, let me note that in. Let me note that. Because I was thinking of, because like most systems would only do a single pass. Like if you're generating an image or you're like generating a video, then most systems would be that. Just a single pass. And as for the training data, so there would be two data sets for this. One is from the Sakuga dataset. That's like a paper release about like an animation dataset recently. Yeah, so that's part of what I'm using, which is gonna be like, I don't know, 20%, something like that. And then there's an in-house dataset that I need to build, which is like scraping all of animation dataset available and using that. Yeah. And yeah, that's the data. And then the architecture, that's what I'm figuring out to do. Yeah. I basically also talk with yeah, I basically talk and reach out to a few animators, and I think that the idea is great. Because like there's like videos online saying like the coloring process sucks and it's like 80-90% labor and there's nothing creative about it. And that's what I'm targeting first. Yeah. There's also like different processes. But let me show you this as well. Let's see. Twitch, no. DeepSeek, yeah. There's this paper, I think. A survey on generative AI. And then there's this diagram here. Wait, it's not. Yeah, okay. Yeah. So there's like pre-production, production, post-production. It's so it's white. Oh man, that hurts my eyes. But basically you got all of these steps for a show. That looks familiar. Yeah. Yeah. So basically pre-production is like planning, scripting, and hiring people and like yeah. Then you got like the storyboard, which is like what is gonna happen for different shots. The layout is like the movement and such. Genga key animation is like animating it. In betweening is like smoothing things, and there's colorization. So yeah, there's also post-production, compositing. So the first thing I'm targeting is this step, making that step super duper easy. Yeah, so just automating that away. Hopefully we can get away with like 80-90% of the work, which is going to be fantastic. And then we can focus on other steps later on, because like the other stuff is like related to the creative process, so I don't want to target that first. Yeah, there's also like models for compositing, but for images. So yeah, that isn't too difficult. A lot of the work in AI is for images and also not for anime specifically. So it's just a matter of yeah, adapting that and like thinking of the right system or tool to work with. Um, but yeah, guess that's that. Yeah. Uh, and of course, there's I have to figure out how to store the data. and work with the limited compute and hardware that I got. So that's also one thing. Let's see. Mm, this is another paper. Yeah. How bad is a limited compute situation? It's if I might ask, yeah, it is. If I want to, I could get more. It's a, it's kind of hacky, um, but I think it's not bad, as you might think. The problem is working with the compute, so it's like software related rather than hardware. The software sucks, really, really, really bad. Yeah. So like a lot of problems are from there. But if I want to get it, I can always get it. Nothing new there, unfortunately. Yeah, yeah. Uh, it's open source too. Um, like even the software itself. This is yeah, this is the Python package that supports this, um, which is maintained by Google and Facebook and such. Um, but they suck. I'm just gonna say it, they suck. There's no support. There's like issues open up, and like I open like issues like within months, and they haven't responded. Um, and this has happened over a span of like 6 months, so it's not something that is recent. Really, really bad. I even reach out to them personally, but not much progress there. Using TPUs, yeah, TPUs. Mm-hmm. I'm getting the hang of it though. Much, much better than the last few months. It seems slightly unsupported, yeah. Yeah. For every new model or every like new paper that comes out, I have to like port the software to work with it, which is like a pain in the yeah, in the ass. But that's what it has to resolve in. Do you see much performance improvement when using them over using a GPU? It depends. It depends, really. Um, I got access to the GH or GB 200. What is it? Like one of the newest NVIDIA Grace Hopper super chip or whatever. And this was provided by the partner that I had before, which recently lost all of their compute. Um, and this, wait, not this one, white paper data sheet. Yeah, I read through this, and it's basically pretty cool. There's like the Grace CPU, which has 72 cores, um, the Hopper GPUs as well. Yeah, 144 gigabyte, I think. Yeah, depending on, yeah, supports 96 gigabyte or 144 gigabyte. Pretty nice. About 500 gigabyte or 600 gigabyte of RAM system memory. Pretty decent, I guess. Not super like, yeah, not not uncomparable to like the TPUs, I would say. I was using like their low end system, so like it was TPU V3, um, V3 8, and that's like the one of the worst. Pretty nice statement, I think. Pretty nice. Yeah, yeah. Like you have to have a lot of these systems. Um, just not one. You have to have like 10 or like 20 of them. I got access to like two or three. which, okay, yeah, I think the GH would absolutely blow away any TPU. Not really. The hardware for the TPU is there. The support sucks. The support sucks. Yeah. So the TPU v3.8, I think I have my stats up here. Maybe no. Okay. TPU v3.8 system specs. Shows my lack of knowledge. So, even the specs are wrong. God damn. Yeah. So basically, TPU v3.8. You know what? Let's try Excalibur. Heard that initial v1, v2 wasn't very good. So for example, the v3.8, for example, let me zoom that in. Zoom in, yeah. v3.8 has like they have like 4 different chips for so like 8 refers to the number of chips, or yeah, device as well. Yeah, let's just say this. Yeah, and it's like, yeah, there's like 4 device, 4 chips, yeah, 2 chips, 2 chips per device, let's say. Yeah, 2 chips per device, and each device is another 2, I would say. That's usually how it works for TPU v2 and TPU v3. Yeah, so we'll divide up into this kind of hierarchy, and then there's like 16 gigabyte, you could say TPU, for example. Yeah, something like this. So basically, you've got a total of 8 devices. So this is what I'm using right now. It's about 128 gigabyte of HBM2, I think, HBM2 memory. That's what I'm using right now. For V2, V2.8, you could get a lot more configuration, but like more powerful configurations, but it's generally not available to you. This one is like 64. Yeah, and this is what I'm using right now. You got 8 devices, each of them is like 16 gigabyte. Of course, there's like a lot of problems with working with a lot of devices, so you have to do like parallelism and like to work with like the different devices, and yeah, that means that the hardware is kind of there, even for like such a low spec system. There's like v3, like, I don't know, 1024, I think. Yeah, 1024. I don't know how much this is, but like, yeah, you could do the math. That's like 200 and like 200, wait, something like that. Yeah, that's like the one of their biggest systems. 128 times 128, something like 16,000 gigabyte or something. But yeah, usually you would only have access to these systems. That's what I'm using. And of course, the software sucks. So yeah, gotta work with that. Of course, I can always quote unquote get more compute, which is not a problem. But yeah, the software still sucks. So I need to figure that out. I haven't heard of V1 though. V1 was probably bad. V2 was a bit less bad, worse. V4 and above was good though. Yeah. V4 has like 32 gigabyte per device, and so you would have 256 in total for like V4 8 before 8, yeah. But if the software sucks and it's blocking process, certainly switching to GPU would be better in short term. If the software, sorry, the software isn't gonna improve much. I'm just gonna say that, yeah. It's been like, there's been issues since like 2020, and the team, the Google team working on XLA, the compiler for TPUs, hasn't done much. Yeah, certain people, I'm not saying every one of them, but like most of them are not working on much. So I don't know about that, but and also we don't have, I don't have GPUs to work with. Um, the only thing I get access to is the TPUs. Yeah, so gotta work with what I have. Of course, it would be better if we have GPUs, because even there's a lot of things that are good with this software. It's just that the support isn't there. Um, this compiler also works on like GPUs, not only on TPUs, but it's really good for certain tasks. Massive shame. Yeah, yeah, absolutely. There are some good things about that. It's different from normal, um, yeah, normal machine learning mode, which they call eager mode. So their mode is like lazy, is what they call it. A bit more technical, but yeah. I I was trying to figure out how to run Deep Speed and the new DeepSeek R1 model, both of which I couldn't get to work. Yeah, which is a lot of hassle. So yeah, let's see though. Let's invite links here. It hasn't expired. The Discord just lost its nitro for a few days. Let me send you a new one. Let's see. Copy link. Invite people. This here. That should do it. Yeah. That should do it. No problem. No problem. Yeah, I guess the next step for me is trying to figure out all of this. Yeah. To storing the data, well, I kind of have scraped the data, so it's just a matter of storing it, um, training the model, figuring out the architecture, and yeah, that's basically that. Not gonna have a lot of support anymore in terms of, yeah, in terms of the compute lab I was working with. But oh well. The Discord is pretty dead. Yeah, pretty much dead. There isn't much yet I used to use it for just testing some image and video models. Um, yeah. Support. Nope. No support. Who's this? Lower thumbs? What? Yeah, probably a guy at Microsoft. Hmm. See what I can do. I'm gonna have to think about this. Yeah. Hmm. Oops. Uh, yeah. I need a storage server. Um, link to data. Some kind of NAS or network file storage. Then we need to store that, I guess. Fundamentally, your input is two frame, one uncolored, and the one colored? No. No, no. It's two frame, one uncolored, and one colored. That's basically like cadmium, is what you're describing. So basically, you would have like what they're doing here is like you have your animation and then you input like the middle frame or something, and that would color in based on the single colored frame, and it would colorize the remaining frames, kind of, which is what you're describing. My idea though would be something like this. Let's see if that loads. Something like this, but with more control. You could use some sketches with your animation, and then based on the reference, it would color in the animation. Yeah. This here is still pretty bad and it cannot be used in production. And so you could see like a lot of different results for different references. There's also like flickering. This is yeah, with a pretty old architecture as well. The resolution that was trained on it was low. So yeah, still a lot of artifacts, things like that. My goal would be to train a more refined model, bigger resolution, better architecture, um, yeah, and actually use it in production. Does that make sense? That isn't Gojo? Which one? Wait, there's no Gojo here? Oh yeah, Satoru Gojo. Oh yeah. Yeah. Not not Gojo, but yeah. That's the gist of it. Yeah. I have to figure this whole thing out. Yeah, I was working with a few people on this. Um, but yeah, this is, well, probably gonna have to work on this alone. So download, need to download like 100 terabytes of animation, and I have to store that, which yeah, as a starting point, is a model for previous repo not documented anywhere. 100 terabyte, yeah, 100 terabyte. Probably closer to 200 terabyte, given the higher quality videos and whatnot. So yeah, no chance of compression. Compression ruins the result though. The data is compressed and yeah. Yeah. Compression then ruins the data. So don't know how much compression can we do. Story code data with lossless compression should be issues. Just uncompressed when data is needed. Hmm. RLE? What is RLE? I was using what was it called? Um, I don't remember. Was it FFmpeg? Yeah, FFmpeg for some compression. There are a few colors. Run line coding. Lossless A compression. There are a few colors and large boxes of similar pixels in each frame. I guess depends on the container format of the animation. Hmm. I guess the training data would look something like this. Where you just have like references and have like a character animation. Most likely, like, you would not only have one reference and multiple ones, so yeah, it is likely that rather than one clip, you could have like 10 different training data for that single clip. The container probably already introduces compression. Also allows the compressor built into the encoding schema. Yeah. I don't think I could use JPEG. I don't think. Because PNG for sure. PNG for sure. No? Not that? Yeah. Yeah. Because I need the alpha channel as well. Yeah, lot less. Lots less. I would, yeah, for like the clips, I would need the alpha channel as well. So, not only images, most of them are gonna be, I think it has to be full HD at least. Um, I don't even know if it's possible for 2K or 4K, or if that's like possible with like upscaling, but I'm scared that training upscale shouldn't be a problem if, well, if your data is already large enough, your resolution is large enough with this space there. I don't. I'm gonna figure that out. I'm gonna buy lots of HDD. Not noticeable artifacts with upscaling still? Could be. Could be. You hmm. Not really. It happens more so when you're training or using really small resolution, then introduce like new data. Like for example 360p to like 4K, then definitely it's gonna be bad. But if you do something like 1080p to 4K, then it's not going to be a big deal because like it's just like yeah, inserting more color and like pixels. It's not introducing new per se. Just doubling the resolution. Yeah. hmm I don't know. Like, does does animators work in 4K by default? Like, I don't think that's like a thing, right? So, of course, it's gonna be useful, but like, it's not necessary. Not asking the model to add 60 new pixels for each one. Hmm. Resolution is a different thing, I guess. But of course, I can't compromise on the like. If you go from 1080p to 2K, you probably won't notice any difference. Um. Yeah. So it's not a big deal. I would say there. So upscaling should be fine. The only problem is if you go lower than that, like 720p, 480p, 1080p, then there's a big difference. And you lose more data that way, trying to train the model. So yeah, this one is like, I don't know, like 512, 312, 320, which is like not even 480p, I think. So there's like a lot of artifacts. And it is trained on an older architecture, so it requires less compute. Given like more resolution and more compute and more newer architecture, then it should give better, significantly better results, but also more compute. At the cost of compute. Yeah. Don't know if I have a result here. There's always a catch. Yeah. There's always a catch. Yeah. I tried this before. I tried upscaling before. It works when you have really low resolution. It doesn't work when you have low resolutions. Just throw more compute at the problem. Easy. Easy. Just throw money at the problem. Everything's solved. Yeah. And I guess that shouldn't be a big issue, because yeah, like for example, they're working here with 14 frames. That's very little compared to video generation nowadays. They can do up to like 200, 300 or something. It's totally possible. Preferably, I would only target like a single second of 24 FPS at maximum, and that should be fine, to be honest, for just starting out. Yeah, so not a big deal. Maybe, maybe. At least that's what I'm thinking. But definitely the data has to be at least 1080p. We can always compress it, I guess, from 4K to 1080p and whatnot. Pre-process. I guess each of the arrows is a process of its own. Share out 24, so 14 terabyte. Oh god, yeah. It's a lot, yeah, it's a lot. There's like, let me see again what the stats were for that. If I remember correctly, there's 3,000 movies, 12,000 shows, a total of 15,000 shows and movies. Yeah. Average movie length 60 minutes. Average episode 21. Average episode duration 20 minutes. Yeah, a lot. 15,000 total episode. 128,000 episode. Insane. All of which has to be in 1080p at least. What did I calculate it? Something. Probably a very silly question. Yeah. Feel free, feel free. Let's see. Terabyte. not the main channel. Oh, this one is. Yeah. With this coloring, do people actually go frame by frame and manually drag and drop colors from palette onto individual parts of the frame, like with the bucket tool? And yes, 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 they do. Yes, they do. There are tons of videos on this. Um, it's a pain. It's painful. Yeah, coloring sucks. Yeah, like there's a lot of videos about this. This is like the so basically like here you can see like they're going frame by frame, coloring each frame like the color, fixing things, and this is just a few seconds. Um, yeah, you can see like there's spills over like the different frames, like they have to fix that. Yeah. So not write out a tool that looks at the current frame and the previous frame and figure out the edges of each line art segment. Then simply copy the previous color is possible. That then the workers reduce the error checking these guesses. There is. There is. But surely the bulk of the work is done. Not really if you have detailed work. Um, and you have a lot of coloring and shadows to work with. Maybe. But it's like cadmium again, where you kind of interpolate the different colors of the frame. It's just that it is really dependent on you having a single frame colored. So like you have to have single frame colored like this, and then you kind of figure it out what the other work is like. There's also papers on this. Let's see, inclusion matching, and this one is like the best so far to trying to do that. I don't know if it's this one or that one. Let's see. Is it this one? Guess not that one. Maybe there's a video of this. Is there any? Learning inclusion matching. Yeah, demo. There's demo here. Do they still have the color? That's not good. I remember I watched this. Yeah. Drawn. They use synthetic data set. Yeah. So they're comparing against the cadmium app that I showed. And so basically it's like, yeah, it's like using one of the frames of the animation and then coloring based on that is what they're doing here. Yeah. I guess they just have a better model to work with, and so the result is much better. Yeah. It looks like, yeah. I tried it. It looks broken. This is like the closest. This paper here, inclusion matching for animation paint bucket colorization, is using the previous frame and then just kind of interpolating that. Yeah. Which is, yeah, they produce much better results. I don't know the resolution that they work with though, if they even stated that. Resolution. No. Not sure to be honest. what resolution are they working with. But resolution is a big thing because it affects data. And also, they have a data set here. Very small though. But something like this could be used in production. They don't state that. That's weird. Yeah, weird. Coloring line art. You have your code here that could do inference. There's no specs, I would say. So support our resolution and unclose line art images. Yeah, this seems like the closest. Yeah, there's cadmium and then there's this one. Maybe I can try this out. Mono inference. New keyframe colorization architecture. New paper. 25th of October 2024. Character color design, keyframe. Yeah, basically what they're doing here. Data. Reference frame. Yeah, most of which is based on. Okay, this here looks good. Ground truth. There's some problems there, but it's not bad, I guess. Yeah. Of course, there's building out the tool for it as well, which is part of why most of these research are only research. Yeah. Thanks for the stream. Yeah. No problem. No problem. You have to head off. Getting a bit late. Yeah. Feel free. Feel free. Good night to you, and I'm gonna keep working on this. See. I'll actually try this out. Let's clone that. Install. Ooh. User. And I need to install it. Okay. Permission denied. Data download. Details of a dataset. Pre-trained model. You can download the pre-trained checkpoints from the following link. Please place it under the CKPT folder and unzip it. Then you can run the basic test.py for inference. Okay then. Link of Google Drive. What? Basic PPT BBC. Model inference. To estimate the colorized frame without checkpoints, on plain Pumpkin character, you can run. Okay. Let's try the full version. See if I can copy the download link of this. Copy download link. And then just go to this, I guess. Then we download. Yeah. So CKPT. Winget. CKPT. This is the basic BBC. I don't even know what this format is. What is the format of this? .pth? PTH. PTH. And then just using the download link. Does that download? Hundred megabytes. Is it? I have to check again. Yeah, it is. How do I rename a file again? Rename a file. Bash. MV. Okay. MV this. To basic bbc.pth. Yeah. CGPT. That's that. Okay. And then just run the tests, I guess. Basic SR tests up high. No module name torch scatter. Torch scatter. No module name torch scatter. What is that? Pip install torch scattered. I don't even know what this is. Guess it's installed. Simplified process. Training. Yeah, something, and then would you have to download, pre-process its own process? The download part, that's simple. Ooh. Simplified process. Simplified process. Work out this assumption right here that this is the Claring AI. This is what we need, right? Of Yeah. If that makes sense. I gotta test these models out. Don't save. Test paint bucket character dataset. I need a dataset to test? Oh god. Need to sit under dataset? Test. Feed me. Due to copyright issues. Of course, of course. Laughing girl, smoke explosion. Okay then. Let's see their dataset. Paint bucket character dataset. We introduce an innovative dataset named Paint bucket character. This dataset includes rendered line art alongside their color counterparts, featuring various 3D characters, including both Japanese and Western styles. We do not provide download links for the real hand-drawn dataset. Please contact us through email if you want to use it. These hand-drawn frames are only for evaluation and not for any commercial activities. After downloading the dataset, please put it in the dataset basic baby fees dataset. Paint bucket character tests. I see. Do they already have this? PNG. And this is smoke explosion? Laughing girl? Oh, this could be cool. 4 frames? Sure then. Yeah. Sure, 4 frames. 4 frames. 4 frames. Wow. Let's see what they do. Options tests. Laughing girl. Inference line frame. Oh, this is using CPU? Is it? No, it's not. Torch load with map location. Basic BBC. $571. How do you load this? Yes, I need to load it onto. Let's use it on CPU, for example, and see how well it does. Model.CUDA. I knew it. Hmm. What? Why is it not working? None type is not callable. None type is not callable. None type is not callable. Let me see. Mm, this here, I guess. And we got upsample. Yeah, let me import this whole thing. Or actually, I only need this one, I guess. It's fine. We'll figure that out. Device. Torch device. Yeah, so I'm using it here. So let me just import that. Use it here. Let me check if that works. Mm. Now you have a number of steps though. Do we need to care about that? We do, right? We have, yeah. Mm, model inference. Inference frame by frame. Um, yeah. Guess we just try and see. Torch load. Oh, yeah. My load is in CPU as well, so I need to change that. Uh, yeah, so this here. Back at it again. Let's see. It is not running. Not good, not good. Length of line frames to be colored. Does seem to be using memory. Does seem to be using the device. It's very slow though. There's the forward method, which, yes, it returns that, but other than that, not much. Frame by frame. Process the line art frame by frame and save them at a safe path. Inference. This is inference multi. What we basically have is the model is set to no gradients. Then we do test loader, test data in test loader, and this seems to be where we need to sync the device. Okay, so I'm just gonna remove this and then killed off the processes. Python 3.10. And then what we can do is this is test data. Yeah. What we can do is at the end of each step, we can just XOA sync. Yeah, let's import it as XOA sync. Then we run the model again, see if that differs anything. Yeah. Weird. Line art, future warning. Swear is deprecated since version 0.25. Oh god, my alarm. Use image morphology footprint rectangle instead. Don't know how to restore data location of storage untyped storage. Okay. But shouldn't it be loading on the CPU and then it needs to move to the device instead? Let me see. That makes a lot more sense. You probably can't load it on the device as well. Or like not directly. I don't know if there's a big difference though. I don't quite get it. You can load on the device and you can move it to the device. Or more precisely, you can load it on CPU and move it to the device. Now that should load it on CPU and then it moves to the XOA device and then it loads on that. Good. The problem is it is very slow. I don't know why. Very slow. No duty cycle at all. 0.67%. Not even 1%. Yeah, you got autocast as well. So I guess I need to change that. GT AutoCast potential. So for XOA AutoCast, let's see. Automatic mix precision, which is done with where's AutoCast? Torch AutoCast XOA. Yeah, this is the one. Torch AutoCast of XOA. That should do it. The only problem is the model's still running, so I guess we can just convert it to use SPMD instead right away. So that's basically moving to the device, and then what we can do is yeah, we initialize the device, move it to the device, and then after this, what we can do is we can set all of this. For example, just import that. I'm just gonna import that, and then what we can do is use the sharding. So that's just basically doing model FSTP and then model, and that should auto shard the model. I don't think we need to shard the input. We potentially can. It's not necessary though. Yeah. To be noted, the mesh should have an SCVP with the weights and activation will be sharded on. Potentially FSTP and model. Let's see how that works in practice. Potentially we can adjust the ratio as well. Yeah, we should be fine. Well, I guess I'm gonna have to do this. Let me just save yours. The shard output needs to be, yeah, to be given. Define shard output. And I'm just gonna print out that. I'm just gonna print it out. see if there's any fully sharded data parallel. You return the outputs and the mesh, and then basically, yeah, I'm just gonna print out the output to see what it is about. It's a list, so probably we need to shard the list, depending on what it is. $121. Oh, it's not shard output. It's the parameters, rather. Load parameters. Unhashable type of list. Unhashable. Unhashable? It's not shard output then. It's not shard output. It's not shard output. It's loading the parameters, which I know. Can we just print out the model then? Maybe just print out the model would be better. Model loaded. Model. Load params is just loading the model path and returning the full model, not params. So rather than doing FSDB of model, what we can do is to shard it there. So full model FSDB of this one then. we basically are doing is we're sharding it here rather, so at the parameters level. I'm also going to print it out, load the params, so it's going to load the dictionary or the parameters of the model. And we'll see how that works. We'll see how that works. The model wrap by should have a forward method, and so it's not possible to do that here. Not possible. Not possible. Hmm. Where is it doing the computation? I know it's self.model. It has to be. Yeah, self-model is just a model. What can we shard? What can we shard? Or what can we do data parallel on? Or it doesn't need to be? I believe doesn't. If we don't specialize the shard FSDB, then just do data parallel, I think. So maybe just not doing it, and maybe it would work. I doubt it would be, but could be. I doubt it would work. Ooh, okay. Okay. We just print out the model, yeah. We printed out the model, and this is the architecture. Ooh, that's a lot of stuff. Okay. Model loaded. And yeah, we run into the same problem. Oh, I haven't checked if it's loaded on that. Right now it's AutoCAD enable self arc mix precision. Does it load on all devices? That is, yeah. Iteration step self.raf. And in the forward method of raf.py, we're getting close. We're getting close. It doesn't even do the first step. AutoCAD call got an expected keyword argument enable. Enable? Unable. Raf. And in the forward method, you've got autocast enable, but that doesn't work. Cache enable. Enables whether or not it's mixed precision. Yeah. So device type has to be there, like XOA, for example. Because torch shot autocast XOA. And then for iteration in range, oh, here we go. I see. That is what we want, right? Iteration in range of iteration. And it doesn't have, it should have, right? It should have TQDM, because that's what it matters. Or maybe doesn't it? Let's see. Maybe here is enough. Maybe that graph is too small. It's gonna be interesting now, because I have to dig into this no matter what. Yeah. It's gonna be hard, but oh well. That's what we got. Still no. Line 112? Is that not the line that I did it? It's not? Oh, there's another one. I see. Oh, there's another one here as well? What? Okay, let's just set it to autocast of XOA. And we should be good. We should be good. Oh, I'll probably end the stream and then head to have some breakfast. Yeah. And then later on I will stream again.